presentation on dark matter. Well, who am I learning from anyway? Like I said before, my name is Carson Hartley, and this is about dark matter. I'm from Jody Richards Elementary School, also go to 212 Academy on Fridays, and I've been interested in space since I was 2, and my grandma taught me about the planets. My inquiry-based questions are, what is dark matter anyway? How does it work? And how is dark matter different from other matter? Well, what is dark matter anyway? Dark matter, what was that?
It's okay.
Okay. Dark matter, there are two candidates for what dark matter is. Those are axions and WIMPs. Axions are hypothetical, what was that?
Okay, you're gonna have to recast. It's okay, it's not a big deal.
Okay. Sorry. Are you recording this?
Mm-hmm. There you go.
Which one was that? This one?
Nope. You were, yeah.
Axions were hypothetical particles that were proposed by the Pecky-Quinn theory, which stated that the number in theta, this 0 right here, it should range from pi to negative pi, so 3.14 to negative 3.14, but it doesn't, oddly, which gave Robert Pecky the idea that this equation is actually measuring an energy field, and that energy field always must strive to be 0, like all energy fields. That is all energy fields want to be at the lowest point of energy, 0 energy. And any energy field needs a corresponding particle. We did not have a corresponding particle that matched those descriptions, so they made the axion. And WIMPs were proposed by quantum supersymmetry. Yeah, there's people at the door.
It's okay.
Proposed by quantum supersymmetry. Were proposed by quantum supersymmetry, superstring theory, which was a combination of quantum supersymmetry and string theory. Quantum supersymmetry is the idea that fermions, and these fermions or matter particles, had a corresponding boson or force carrier with the same spin and similar mass. Well, no, it's a different spin, because that's the definition of a fermion and a boson. The same mass and the same charge, so opposite charges. I need much research on this part. String theory is the idea that there are 11 dimensions, and the 7 that we cannot see are coiled up, and there are one-dimensional strings that vibrate hyperdimensionally and different vibrations cause different particles. Go. How does dark matter work? It interacts with itself weakly, so it doesn't really interact with its own particles, but it interacts with other particles of baryonic or visible matter, and it tends to be very massive and forms a halo around galaxies, or just big parts of baryonic matter. While we cannot see dark matter, we can see its effect on other things we can see. This graph shows the rotational velocity, the calculated rotational velocity of stars as they get further away from the center of the galaxy. Like here, we have around 9,000 light years. Over here, like 0. and the rotational velocity should be going down, as shown in red, but it's staying around the same, even a spike over here that was measured. Well, there must be some kind of invisible force of gravity. Well, that force of gravity has to be dark matter, because all there is the darkness of space. In fact, that's where dark matter got its name. It doesn't interact with light, making it black, but it does have a gravitational pull. So, dark matter is different from other matter. As I stated earlier, fermions, or matter particles, here, and bosons, or force carrier particles, are here. Well, as I also stated earlier with the axion, it must be some kind of energy field, which would have a force carrier particle, which is a boson, and all matter particles tend to be fermions, like we have the electron right here, and these are different quarks that make up the protons and neutrons that we hear about. Some setbacks are I overthought a lot, and I overcame that by realizing I only had 7 minutes to do this at max. And my questions are, I need to learn more about string theory, and I need to learn more about axions. Oh wait, I didn't make another one. And this concludes my presentation.